All right, here are the video solutions for Test 2's study guide. Let's start with number 1. It says the velocity of the particle moving on a line at time t is given by v equals 5t to the 2/3 plus 6t. How many meters did the particle travel from t equals 1 to t equals 8? So first of all, we need to understand that in order to go from velocity back to a distance, we need to take the integral to go back to position. And we need to keep in mind that we are looking at the distance that the particle traveled. And notice that it doesn't say like what is the difference between where it started and where it ended. That would be displacement. It said how many meters did the particle travel. So they're talking about total distance, which means we need to take into consideration the fact that this particle could have stopped and changed directions and moved in the positive direction and the negative direction, and we need to take all of that into consideration when we are looking for our answer. Now, typically these total distance problems are on the calculator section of the multiple choice test, and so you would just put it in your calculator as the integral of the absolute value of the velocity function. So the absolute value of 5t to the 2/3 plus 6t dt, and then the limits of integration would be from 1 to 8, because that's how much total distance I want to know. And the key here again is the absolute value bars because of the total distance. If they did have it in the non-calculator section, then of course you would be expected to do this without a calculator. So to figure out the absolute value of 5t to the 2/3 plus 6t, you would just factor out a t and then find the two zeros and figure out where it's positive versus negative. All of the positive pieces you would take the integral normally, all of the negative pieces you would just make them positive. But I'm going to use my calculator to solve this because like I said, typically it's in the calculator section. So if I put this in my calculator, I have the integral, math 9. You could put this function in as y1, or you could just type it straight onto your screen. It's up to you. I'm going to go ahead and pause the video as I put it into my calculator, and then I will pull up an answer from there. Alright, so when I put in my calculator, and again, make sure to throw absolute value bars around it when you do that, I got 282 meters. So it must have traveled that far in that time frame of 7 seconds. Number 2 says a particle moves along the x-axis with the acceleration at any time t given as a of t equals that function. If the particle's initial velocity is 10 and the initial position is 2, what is the position function? So again, to get from acceleration to velocity and then from velocity to position, we're taking integrals. So I'm going to take the integral of this function. So the integral of acceleration and the integral of this side. I'll show my work for it over here. When I do that, the integral of acceleration is velocity, so that's v of t. And the integral of the right-hand side, the integral of 3t squared is 3t cubed over 3, which simplifies to t cubed. The interval of 4t is 4t squared over 2, which simplifies to 2t. And the integral of 6 is 6t. And then I'm just going to put plus c, since this currently is an indefinite integral. Now I'm going to use this initial condition about velocity in order to solve for the c value. Initial velocity means when time is equal to 0. So notice that if I plug in 0 for time here, I get 0 plus 0 plus 0. Oops, this should be a squared, by the way. There we go, I fixed it. 0 plus 0 plus 0 plus c, and that should be equal to 10. Therefore, my c value is 10. So, v of t is equal to t cubed plus 2t squared plus 6t plus 10. And then I want to go back one more time, take the integral one more time to find the position. And the integral of velocity is position, so that's x of t. The integral of t cubed is t to the 4th over 4. The integral of 2t squared is 2t cubed over 3. The integral of 6t is 6t squared over 2, which simplifies to 3t squared. And the integral of 10 is 10t plus c. And again, I'm going to use my initial condition, this time the one dealing with position. So it says the initial position is 2. What is the position function? So if I plug in 2 here, when the initial time is 0. So again, initial position is when time equals 0. This will be 0 plus 0 plus 0 plus 0 plus c. So on this side I have c, and it says the position is equal to 2. Therefore c must be equal to 2. So final answer, x of t equals 1/4 t to the 4th plus 2/3 t cubed plus 3t squared plus 10t plus 2, which is answer choice B, it looks like. So B is my final answer there. All right, let's look at number 3. All right, number 3 says if the position of an ant traveling along a horizontal path at time t is 3t squared plus 1, what is the ant's average velocity from t equals 1 to t equals 6? Now remember, anytime we see that word average, there's two ways to find average velocity. We can either use the average value equation, which is 1 over b minus a times the integral of the velocity function, or if we're not given the velocity function, which in this case we're not, notice that they're giving us the position function. So it's either the average value of the velocity function, or in this case, because they're giving us the position, then it's just the average rate of change of the position function. So essentially it's the slope of this function in between these 2 points. So that means I need to know what those 2 points are. If I plug in 1, the position evaluated at 1 is 3 times 1 squared plus 1, which is 3 plus 1, which is 4. And the second point, when I plug in 6, I get 3 times 6 squared plus 1, which is 36. 36 times 3 is 108, and 108 plus 1 is 109. So if I look at the average value, the average rate of change between these 2 points, that's going to give me the average velocity. So 109 minus 4 over 6 minus 1 is going to be 105 over 5, which is 21. Answer choice D. For number 4, it says a bottle rocket is shot upward from a 10-foot stand with a velocity given by that function. What is the position of the bottle rocket after 2 seconds? So again, position. Let's remember how to find position. Position at 2 seconds takes into account the initial position, which is 10. I mean, not necessarily the initial position. It takes into account the initial condition, I should say. So in this case, it's telling us that it starts at 10 feet because it's shot upward from a 10-foot stand. So it starts at 10 feet, and then we're adding on how much area has accumulated in between when it started, which was 0 seconds, and in between the time I'm trying to find right now, which is 2 seconds. And I want to know what is the integral of the velocity function. So I'm going to go ahead and use my calculator to do this, but again, just to break down where this came from, I'm looking for the position at 2. So essentially I want to know where it started, which is 10 feet, plus how much height it's gained in between 0 and 2 seconds to figure out where it is now after 2 seconds. In order to do that, I'm taking the integral of the velocity function. I don't have to throw absolute value bars around it because I don't care about total distance. Like let's say it goes up and comes back down. I don't want to know all of that distance. I just want to know how much higher or how much lower it is from where it started, which is what the displacement will tell me. So I'm going to go ahead and pause my video and put that into my calculator. Why don't you guys do the same and check your answer in just a second. Alright, when I put it in my calculator, I got 106.8. And notice, by the way, that 96.8 is also one of the answer choices. So if you had forgotten to add in the initial height, you would have accidentally gotten the wrong answer. So just be careful that you take into consideration where it started and where it is now. Alright, let's look at number 5, which also has to do with the directions from number 4. It says, when will the bottle rocket hit the ground? So remember, in order to calculate where an object hits the ground, if I can draw a little picture of it, the path of the rocket looks kind of like this, where it starts at this initial height of 10 feet, and it goes up, 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 and then it's going to come down, 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 down. And so it hits the ground wherever the position is equal to 0. So essentially, I want to know where the position is equal to 0. So the first thing I want to do is I actually want to solve for the position function. So I know the velocity function. If I want to get the position function from there, that means I need to take the integral. And then I can use this initial condition about it starting at 10 feet in order to find out my c value. So the integral of the velocity function, v of t, which is 50 minus 1.6t. If I take the integral of both sides, I'm going to get the position function. So x of t is equal to 50t minus 1.6 t squared over 2 plus c. And again, my initial condition is at 0 seconds, it's equal to 10 feet. So if I'm plugging in 0 here, I get 0 plus c is equal to 10, therefore c is equal to 10. So I'm just going to go ahead and fill that in now. So plus 10. Now, if I want to know when my bottle rocket hits the ground, I essentially want to know from my picture that I drew earlier, I essentially want to know where my position is equal to 0. So if I can solve for where this equals 0, I can figure out where my bottle rocket hits the ground. Now, I'm going to go ahead and use a calculator for this, and essentially I'm just going to put this function into my calculator and look at the graph of it, and then from the graph I am going to determine where the zeros are. So again, when I graph it, it should look something like this. And there's a 0 right here. So in your graphing calculator, I want you to graph it and find the x value of that 0. So I'm going to put my screen on pause, and I'm going to do this in my calculator, and then I will come back and tell you the answer I got so you can check your work. Alright, so I put this in my calculator, and I got an x-intercept of 62.699. I don't know about you guys, it took me a minute to figure out exactly where the graph appeared, like a good viewing window to look at it. So using our answer choices probably could have been very helpful. I think I was looking closer to like -10 to 10, and I couldn't see any of the graph. If I would have looked down at my answer choices and realized the numbers were so big, I could have realized to extend my x viewing window all the way up to like 70 to get a nice clear picture of these last couple numbers up here. So if you also had a hard time seeing the window nice and neatly of your parabola, the one I ended up using was x min -10, x max 70, y min was -570, and y max was a +800. So if you had to kind of like zoom out a lot to get a nice clear picture of what that parabola looked like. So if you didn't get a nice clear picture, go back and try that window I just mentioned and see if you can get a better picture that way. Alright, let's look at number 6. Number 6 says the position of the particle moving along a straight line is, and it gives us the position function, on the interval from t equals 0 to t equals 10, when is the particle furthest to the left? Now, keep in mind that when this particle is moving along a straight line, think of it kind of like a number line. So if I'm moving to the right, that would be the positive numbers. If I'm moving to the left, that would be the negative numbers. So for the particle to be furthest to the left, it's essentially like where is it at its smallest value. So for example, maybe like the particle moves to the left, and then it moves to the right, and then it moves back to the left again, and then moves back to the right again. They essentially want to know where is the particle at the furthest point to the left. Or in other words, where is the absolute minimum value? Because if I can find the minimum value for the position function, that will tell me where it was furthest to the left. So the maximum, by the way, will be the furthest to the right point. So in order to find the minimum value, I first need to find all my critical points. So the critical points of the position function would be velocity. So v of t is equal to 3t squared minus 18t plus 15. And I want to know the critical point, so I'm solving for where that's equal to 0. I can divide all these by 3, so that gives me t squared minus 6t plus 5 is equal to 0. This factors to t minus 5, t minus 1 is equal to 0. Therefore, t is equal to 5, and t is equal to 1. Now, if I look at a quick sketch of this function at 1 and 5, this is a parabola facing up, so it looks like this. So if I'm looking for a minimum, notice that 1 is actually a maximum on my graph because it goes from positive to negative values. 5, however, is a minimum. It goes from negative to positive values. So that means I don't even need to explore 1 as an option because I know that it's impossible that that would be a a point that represents when the particle is furthest to the left, because that's actually a maximum value. So I do need to explore 5, however. I do need to plug 5 into this function to figure out if that is the smallest value, but don't forget we also have to test the endpoints, because maybe it was further to the left at one of the endpoints as well. So we're going to go ahead and test these 3 values in the position function. We're going to test the endpoints, which are 0 and 10, and we're also going to test that minimum we found in the middle of the interval at 5. So let's see what I get. If I plug in 0 here, I get 0 plus 0 plus 0 plus 3, so that's 3. Let's do 10, because I think 10 is the next easiest. If I do 10, I get 10 cubed, which is 10 times 10 times 10. That's 100 times 10, so 1,000. Minus 9 times 10 squared. Well, 10 squared is 100. 9 times 100 is 900. Plus 15 times 10, that'd be plus 150. And then plus 3. Now, I don't even need to know exactly what that's equal to. I just know that 1,000 minus 900 is 100. 100 plus 150 is 250. I guess I could figure it out pretty easily. But 250 plus 3 is 253. So obviously that one's bigger than 0, 3. So this one is not when it's furthest to the left. And last but not least, we need to test 5. So if I plug in 5 here, I get 5 cubed, which is 5 times 5 times 5. That's 125. I get 9 times 5 squared. So 5 squared is 25. And 9 times 25 is 225, so that's minus 225. 15 times 5, so 15 times 5 is going to give us 75, plus 3. So 125 minus 225 is negative 125. Sorry, negative 100, excuse me. 125 minus 225 is negative 100. Negative 100 plus 75 is negative 25. And negative 25 plus 3 is negative 22. So that is definitely my point that's furthest to the left. So the t value that makes that happen is at t equals 5. Therefore, D is the correct answer because that is the smallest value, which means it's furthest to the left. All right, let's look at number 7. So in number 7 it says the graph given above is y equals v of t. So this is a graph of the velocity function, and it's the object moving on a line over the time interval from 0 to 8. It says at time t equals 0 the position of the object is 5. Part A says when is the object at rest. So if this is the velocity function, the object is at rest wherever the velocity is equal to 0. So it's at rest at 5 seconds as well as at 8 seconds. So for A, the answer would be at t equals 5 and t equals 8. Part B says evaluate the integral from 1 to 6 of v of t dt. So notice that I'm actually able to take the area under the curve by splitting it up into some nice shapes I know how to find the area of. So for example, this first rectangle over here is height of 1 and a base of 1, so it's 1. This next one is a base of 3 with a height of 3, so that has an area of 3. This little triangle right here has a base of 3 with a height of 1, so that has an area of 1.5. This little one over here, base of 1, height of 1, so it has an area of 0.5. And then this taller triangle right here has a base of 1 with a height of -2, so that has an area of -1. So if I add all of those together, I get 1 plus 3 plus 1.5 plus 0.5 minus 1, which is equal to 1 plus 3 is 4. 4 plus, this is 2, is 6. 6 minus 1 is 5. So 5 is the area under the curve in between 1 and 6 of the velocity function. It says explain the meaning of the result. So the meaning of the result is that's the displacement. So it is 5 units away from where it started at the very beginning. So it's not the total distance traveled because of the fact that this is a negative. It backtracked a little bit. So it's not the total distance traveled, it's only the displacement, how far away it is from where it started. Looking at part C, it says what is the position of the object at t equals 5. So looking back up here at the graph, let's see if I can zoom out just a little bit so you guys can see all these questions at once. There we go. So for part C, it says, what is the position of the object at t equals 5? Well, that would be essentially where it starts. So notice we have this initial condition. It starts at a position of 5. So the position at 5 seconds would be, it starts at 5 seconds when time is equal to 0. And I want to know how far has it traveled in between 0 and 5 seconds. So essentially, I'm going to add 5 to whatever the area under the curve is in between 0 and 5. And we just talked about how the area under the curve in between 0 and 6 was 5 because of the last little minus 1. But if we don't count that and we stop here at 5, it would just be the areas of 1 plus 3 plus 1.5 plus 0.5, which gives us 6. So it's 5 plus 6, which is 11. So the new position is 11 after 5 seconds. Part D says find the total distance traveled from 0 to 8. So remember, this is the one where we ignore the negatives and we treat them as positives. So if I come back up here to my graph one more time, I know that this little triangle has an area of -1, and I know that this little triangle has an area of -1. And I know this rectangle in the middle has an area of 2, -2. But if we're just going to add, so we already know that over here we have an area of 6. We added these, 1 plus 3 was 4, plus this 2 was 6. And again, for total distance, I'm going to take the absolute value of this. I want to know, without backtracking essentially, tell me how much distance I covered. So we're going to take 6 plus 1 to be 7, plus 2 to be 9, plus 1 more to be 10. So the total distance traveled was 10 units over the course of those 8 seconds. Last but not least, part E says at time t equals 2 is the object speeding up or slowing down, and explain your answer. So if I come back up here to my velocity function, time t equals 2 is right here. And remember, in order to figure out if a particle is speeding up or slowing down, we're looking for 2 things. Number 1, we're looking for whether or not velocity is positive or negative. So if this is a graph of the velocity function, knowing that when time is equal to 2, the velocity is equal to about like 1.5, tells me the velocity is positive. So that's the first thing I want you to note. Velocity is positive. And the second thing I care about is acceleration. So acceleration, because the velocity function is increasing, that means its derivative has a positive slope at 2. So the acceleration, being the derivative of velocity, is also positive. And since velocity and acceleration are the same sign, it means that we are speeding up. Remember, that's kind of like from first semester, we talked about the example of walking, like me walking in the positive direction and then a big wind comes up behind me and pushes me in the positive direction. That would force me to speed up because they're both the same sign. Alright, let's look at number 8. Number 8 wants to know what is the, or given I should say, that g of x is equal to the integral of pi to pi of x of cosine of t squared dt, then g prime of x is equal to blank. Now remember that when I'm working with an integral, when I take its derivative, we call that the second fundamental theorem of calculus. And the second fundamental theorem of calculus says when that happens, when essentially I'm taking the derivative of this, g prime, which is d dx, the derivative and the integral are inverse operations and they undo each other. So all we have to do is take that value we're working with and plug it into the function. And then don't forget to multiply times the derivative of what we're plugging in because of the chain rule. So this is equal to cosine of pi x quantity squared, and then times the derivative of pi x, which is just pi. So it's pi cosine of pi x squared, which is answer choice E. Number 9, same thing. The derivative of the integral. The only difference is that notice that sine of x is on the bottom. So if we had performed the actual integral and found the integral algebraically and then done the fundamental theorem of calculus, we would have gotten a negative answer for this. So because of that, we're just going to flip our integral upside down and make it negative. So when I do that, I get a negative derivative of the integral from 4 to sine of x, and then the square root of 1 plus t squared dt. And then we go back to the same thing. Plug in sine of x everywhere you see a t. So this is going to be the square root of 1 plus sine of x quantity squared. And then times the derivative of sine of x. And the derivative of sine of x is cosine of x, which is answer choice. Oh, and don't forget about that negative in front. The negative from right here follows my answer as well. So this is negative cosine of x times the square root of 1 plus sine of x squared, which is answer choice B. Number 10 says, what is the average value of that function on the closed interval from -1 to 9? Let me unpause it so we can move it up just a little bit. Number 10 is asking about the average value of this function. So remember, the average value formula looks like this. It's 1 over b minus a, so 3 minus -1, of the integral from b to a, from -1 to 3, of this function of y dx. Maybe I shouldn't write it like that. Maybe I should write the actual function out. Cosine of x over x squared plus x plus 2 dx. And I'm going to go ahead and put my calculator to work to do this problem for me. So literally this problem is super, super easy points on the AP test as long as you can remember the average value formula in order to find the value that it's asking for. So I'll put my video on pause. Why don't you do the same? Put this in your calculator and see if you can get a correct answer. When I put it in my calculator, I got answer choice C. Number 11 says, the velocity in feet per second of a particle moving along the x-axis is given by that function. What is the average velocity of the particle from time t equals 0 to time t equals 3? Again, they're giving us the velocity function and asking us for the average velocity, which means we're going to go ahead and plug that into the average value function. So it's 1 over b minus a times the integral from b to a, or a to b, of the velocity function, v of t dt. So again, pause your video, see what you get when you put that in your calculator, and then unpause it to check your answer. When I put it in my calculator, I got answer choice A, 20.086. Number 12 and 13 say, the volume generated by revolving about the x-axis, the region above the curve y equals x cubed. So let me draw this. Here's the function y equals x cubed. So it's the region above this curve. It's below the line y equals 1. So here's the line y equals 1. And it is between x equals 0 and x equals 1. So I'm looking at these two bounds right here. Which means the area they're talking about is this area in here. That's the area, the green shaded region is the area that's above the curve y equals x cubed. It's below the line y equals 1, and it's between 0 and 1 on the x-axis. They want to know what the volume is of that region when it's rotated about the x-axis. So I'm going to erase this picture and draw it a little bit bigger so we can look at it in its entirety. So, and essentially what we're looking at is this function with this area right here, where this is the graph of x cubed, this is the graph of y equals 1, and my bounds are 0 and 1. Now, if I'm going to rotate this around the x-axis, I can reflect it over the x-axis first. So that's going to look like this. And if I show my circles to show the cross-sections, here's the inside cross-section. Actually, I think I've always done it in color with red on the outside. Here's the outside cross-section, and then in green, here's my inside cross-section. So if I'm looking for the radius, I need my outside radius and I need my inside radius. So in red, I'll write the red one first. My outside radius, capital R, is going to be top function minus bottom function. So the top of this function is 1 and the bottom is 0. So 1 minus 0 is 1. And then my inside radius, little r, is equal to the top function minus bottom function. The top function is this cubic graph, x cubed, and the bottom function is 0. So x cubed minus 0 is just x cubed. If I put these into my equation for volume, I get that volume is equal to pi times the integral from 0 to 1, from left to right, of big R squared minus little r squared dx. And I'm going to go ahead and pause my video. I'm going to put this in as y1 and this in as y2 and pause my video and put that in my calculator and see what I get. The only thing I'm not going to do is I'm not going to multiply it by pi, because notice all of our answer choices have a pi left in them, which means if I multiply it by pi, I'm just going to have to divide it by pi again anyway. So figure out what the value of the integral is, and then just show me how you multiply it by pi, and choose one of the answers that actually equals what you're supposed to get. So pause your video now and calculate that. So when I put it in my calculator, I actually got 0.857 pi approximately, which I know is equal to 6/7. So I think the reason that they have this as a fraction, typically on the AP test they would actually multiply this out to get the decimal version of it. The reason they have it as a fraction, I think, is because technically this problem is easy enough where you could take the integral by hand, but we'll just use a calculator on it since it's typically not in the non-calculator section. So anyway, 0.857 pi is the correct answer, but it's equivalent to 6/7 pi. And then for number 13, it says find the area of the region bounded by the parabolas y equals x squared and y equals 6x minus x squared. So if we look at that region, y equals x squared looks like this. And the other one, y equals 6x minus x squared. So that's another parabola. If we look at the zeros of it, x times 6 minus x, I have zeros at x, and I have a 0 at 6. So a 0 here and a 0 here. 1, 2, 3, 4, 5, 6. And it is a parabola facing upside down because it's a negative x squared. So it looks like this. And we're looking at this region right here, the area bound by the two graphs. So I know that the left bound is 0. The right bound, however, I'm not quite sure until I actually set these equal to each other and solve. So typically we could do this in a calculator and just find the point of intersection, but let's try to do this one by hand and see if we can actually do that. So in order to figure out the other point of intersection, all you need to do is set these two functions equal to each other and solve for the x value where they meet. So if I do that, I get 6x minus x squared is equal to x squared. If I bring this x squared over to this side, I get 6x minus 2x squared is equal to 0. If I factor out a GCF, I get 2x times 3 minus x is equal to 0. Therefore, my zeros are at x equals 0 and x equals 3. So those are my bounds, x equals 0 and x equals 3. So, if I'm trying to find the area between these two curves, the integral I'm setting up for area is, remember I don't need a pi because I'm not looking at volume in this case, it's literally just the integral of my left to right bound, and then top function minus bottom function. So in this case that's 6x minus x squared, that's the top function, minus the bottom function, which is x squared dx. And again, we said we're going to try and do this one by hand, so that would be the integral from 0 to 3 of 6x minus 2x squared dx. The integral of that is 6x squared over 2 minus 2x cubed over 3, and then from 0 to 3. If I plug in 3 to that function, I get 6 times 3 squared, that's 6 times 9, which is 54 over 2. Minus, if I plug in 3 here, I get 3 cubed, which is 27. Then this 27 and this 3 simplify to 9, and then 9 times 2, which is 18. 54 divided by 2 is 25, 26, 27, so 27 minus 18. And 27 minus 18 is equal to 9. Which means the correct answer is A. So again, that one probably is not going to appear in the non-calculator section, but why not just get some practice doing it? So 9 is the correct answer for the area between those two curves. All right, let's look at number 14. All right, number 14 says, what is the area in the region in the first quadrant enclosed by the graph of y equals e to the power of negative x squared over 4 and the line 0.5. So I'm going to go ahead and put this in my calculator now, as I suggest you do as well. So my y1 is going to be e to the power of negative x squared, e to the power of negative x squared divided by 4. And my second function is going to be y equals 0.5. And I'm going to look at this in a nice viewing window from negative, I don't need to go negative 10 to 10 actually, because it's only the first quadrant. So why don't I go 0 to 10 on the x window and 0 to 10 on the y window. It's probably going to give me too much of it, but that's okay. Alright, so yeah, I think that's a little bit too much. So I'm going to change my viewing window from 0 to, let's say, 3 on the x-axis and 0 to 1 on the y-axis. So 0 to 3 x-axis, 0 to 1 y-axis. When I do that, I get a nice clear picture of this function, and it looks like this. So this is the function e to the negative x squared over 4, and this line right here is the function y equals 1/2. And they want to know the area of the region in the first quadrant that's enclosed by these two. So that would be this area in here, because that's the area in the first quadrant that's enclosed by those. So first things first, I need to know the left bound, which I already know is 0. So to find the area, I'm looking at the integral from 0 to, now I need to know this point right here, that point of intersection, so I can figure out where to stop it. So I'm going to go ahead and look back at my calculator and find that point of intersection. If you want to pause your video and do the same, that would be a good idea. And when I did that, I got that the point of intersection was 1.665. 1.665. So my area is going to be the integral from 0 to 1.665 of the top function minus the bottom function. So that's e to the negative x squared over 4 minus the bottom function minus 0.5 dx. So go ahead and pause your video and put that in your calculator and see what you get. Unpause it to check your answer. When I put it in my calculator, I got 0.516, answer choice B. For number 15, it says, what is the volume of the solid generated by rotating about the y-axis, the region that's enclosed by y equals sine of x, and the x-axis from x equals 0 to x equals pi? So let's draw a picture of what this looks like. First of all, y equals sine of x looks like this. We are looking at the region that's enclosed by that function along with the x-axis, which is this axis down here, from x equals 0 to x equals pi. And so essentially this is the region we're rotating right here. Now, the thing that you need to keep in mind is that we are not rotating it around the x-axis. We are rotating it around the y-axis. So I need to reflect it across the y-axis. And when I draw my rings to show the washer, there's my red one. Here's my green one. And remember, when you're finding your capital R and your lowercase r, you need to tilt your head to the side. So tilt your head to the right. My capital R is top function minus bottom function. So in this case, it's the sine curve minus 0. However, we cannot keep sine in terms of x since we are revolving around a vertical line. So in terms of y, if I solve for that in terms of y, I get y equals sine of x. If I take the inverse sine of both sides, I get that sine inverse of y is equal to x. So that is the function I have to use. R equals sine inverse of y. And then for little r, lowercase r, it's the inside function minus the x-axis. which actually in this case is still the sine function. Oh. Alright, so forgive me. I will definitely delete this problem from your study guide right now. I didn't realize that it's this problem. It looks very similar to ones that we would be able to do, but we're actually not able to solve this because this is a different method of finding volume. This is called volume using the shell method, and that's not something we learned because it's not something the AP test requires anymore. They used to require students know how to do the shell method for finding volume, but they do not ask us to know how to do it anymore. Anyway, long story short, you do not know how to do this problem because of that. So I'm going to go ahead and skip it now in the video, and you won't even know it existed because it won't be on your review guide by the time we get there. So ignore this problem. Don't worry about it because it will not be necessary to know for the AP test or for your test in class. So ignore number 15 and let's move on. Number 16. Says the base of a solid is a region in the first quadrant bound by the x-axis, the y-axis, and the line x plus 2y equals 8, as shown in the figure to the right. If cross-sections of the perpendicular solid perpendicular to the x-axis are semicircles, so remember that semicircles perpendicular to the x-axis would look like this. There's one little semicircle. So if they are perpendicular to the x-axis and they're semicircles, what is the volume of the solid? So first things first, let's rewrite this equation in terms of y, or sorry, in terms of x. So if I subtract x from both sides, I get 2y equals negative x plus 8. And then divide by 2, I get y equals negative 1/2 x plus 4. So that's the equation we're going to be using here. And remember, in order to find the volume, I essentially need to know the integral of left bound to right bound, that would be 0 to 8, of the area dx. So if I can find the area of one of these little semicircles, then this integral will add together the area of all of the semicircles for me, all the way from 0 up until 8. Now, this obviously is not enough on its own. I also need to know an expression to represent the area. So the area of a semicircle is pi r squared, which is the area of a circle, but then divided by 2. Because it's only half the circle. So we're getting there, getting a little closer. The only thing is that I need an expression for r. So the radius of this semicircle would be the top function minus the bottom function, and then that would be the diameter, so divide that by 2. Now the top function is right here, negative 1/2 x plus 4. The bottom function is 0, so it's going to be negative 1/2 x plus 4, which is the diameter, top minus bottom, so we have to divide that by 2. So remember that when you're putting this into your calculator, the radius gets plugged into this function, and then that function gets plugged into the integral. So the easiest way to do it probably is to set up this function as y1. So if you set up pi times this whole thing squared divided by 2, and you put it in really carefully, making sure to put lots of parentheses around what you're trying to group together, then you can go back to your home screen and calculate this integral. So I will put my screen on pause as I do that. Why don't you guys go ahead and pause the video, and that way you can pick up and check your answer when you're done. Alright, so the answer I got was 16.755. Again, be very careful as you're plugging in the radius into this function and then taking the integral of that. So I believe I did it all correctly. That should be the correct answer. Alright, number 17, the last one from your review. It says, a pool has 100 gallons of water in it. When a hose is turned on and starts to fill the pool, the water flows in the pool at a rate modeled by the function r of t equals, I typed this, I obviously made a little oversight. These should be t's, not x's. R of t equals t plus sine of 3t. How much water is in the pool after running the hose for 4 hours? So, I essentially need to know how much water was there to begin with, and that should be 100 gallons, plus, over the time of 4 hours, from 0 to 4 hours, how much water has been added. And I can figure that out by taking the integral of r of t dt. So the integral of this, if this is the rate that water is flowing, the integral of that will tell me how much water has flown in, because this is the accumulation function. So the integral from 0 to 4 of the rate that it's flowing will tell me how much water has been added to the pool in between 0 and 4 hours. And if I add that to how much was already in there, it will tell me how much water is in the pool now. So if I go ahead and put that in my calculator, I'll pause my video as you guys pause yours so you can calculate that as well. Alright, so I got 108.052. So it's a very slow flowing hose, I'm guessing, if after 4 hours it only gained 8 gallons of water. So maybe they don't have the hose turned on very high. Anyway, that is the end of this review. That should get you guys pretty good in terms of if you understand how to do these problems. The test should be fairly straightforward as well. Alright, that's it.